Oh, okay. I got 52 minutes left of recording, at which point it will stop recording.
Let's just start out with the simple box pulling box on rope. And the question is, what is the acceleration of the boxes? It is an ideal rope so that the acceleration of the boxes will be the same. If box 2 moves a centimeter, box 1 moves a centimeter. If the box was able to stretch, it is possible that they would have different accelerations, and that really was a pain. So we will not deal with that. We did the force diagram earlier today. I have weight acting down. I have tension acting to the right. I have normal force up, 1, 1, 1. I have friction acting back. And then box 2, I've got weight acting down, tension acting up. There are other parts. When we did the force diagram before, we included the rope and the ground. Ultimately, if I can figure out the acceleration of these two boxes, I don't need anything else. I don't need the rest of it. So step 1, force diagram, done, check. Step 2 in our Posad's method, acceleration. This is your best guess based upon your own knowledge of the way things move. Which way will box 1 accelerate, if it does accelerate? Okay. This is not part of the force diagram. Please do not draw the arrow on the box if I ask you to do a force diagram. Which way is box 2 going to accelerate if it does accelerate? Down. All right. That's all that the A is. You figure out what the direction of acceleration is. Now in this case, I think it's very clear which way they will accelerate if they do. However, there are situations where you don't know. The coordinate axes. Strongly recommend you have, when you set up your coordinate axes, the I hat, J hat, one of them is in the direction of acceleration, the other one is perpendicular to it. So in this case, now we put, if I can put I hat to the right here, I have 1 hat, and then J hat, J1 hat acting up or down for J hat, really doesn't matter. I1 hat to the right tells me that I'm expecting acceleration to be positive. If acceleration is negative, that means either I got my direction of acceleration wrong or it's not moving. But we will get to that. Down here, I'm going to set up my coordinate system. I do not have to use the exact same coordinate system I used there. This is a different object, a different set of forces. So I'm just going to choose down to be J2 hat. If you like I2 hat, fine. I don't need a perpendicular coordinate to that because I don't have any forces perpendicular to that. If you want to put an I2 hat in there, knock yourself out. Questions to hear?
Decomposition of vectors.
All right, so now the decomposition. Are there any of the vectors, any of these force vectors, that are not parallel or perpendicular to my coordinate axes? Parallel, anti-parallel, or perpendicular? I think, Jack?
I don't think so.
All right, if there are none, decomposition phase, done, we don't have to do anything. Equations of motion. Equations of motion are based upon Newton's second law of motion. The fact that the force, the total force acting on an object is equal to the mass of the object times its acceleration. In this particular case, I'm going to have 3 equations of motion. I'm going to have 1 equation for the vertical here, I'll have 1 for the vertical here, and 1 for the horizontal here. Any place where I have to have a sort of an axis, I'll have an equation for it. So I'm gonna have an I1 hat equation, a J1 hat equation, and a J2 hat equation. Some students like put an equal sign after it. Please don't put an equal sign after it. This is not part of the equation, this is just a label so I know which equation goes, so I'm keeping track of my equations. When filling this out, we set up given our coordinate system, what are all the forces in the positive I1 hat direction?
Tension.
Anything else? In the positive I1 hat direction.
No.
How about all the forces in the negative I1 hat direction?
Friction.
So it's the ones in the positive direction minus the ones in the negative direction equals, because that's all there is, mass 1, please don't forget subscripts there, times the acceleration. We said the acceleration is going to be to the right, and it is a value of a. That is our first equation of motion.
No vector.
The vector, technically there's an I1 hat after every piece of it, but in a sense you cancel that out. Questions about coming up with this equation right here?
So you, for the force, you take the opposite forces acting on each other, and that's that?
I mean, you've got the ones in the positive direction minus the ones in the negative direction, so
Right.
that's what you do with them.
Okay.
So, for whatever reason, you just flip it, like, if you flipped it over, so I hat would be to the left,
Right?
would
Correct.
they just flip?
Then if you had it to the left, there's one tricky part there. If we, depends on what we're saying with the acceleration. If we're saying that it's gonna accelerate to the right, and we have, that's the positive direction, then the equation would become F1 minus FT equals M1 times negative A.
You just change
So
the acceleration.
don't forget that sign too.
Okay. But it's the same, just change the acceleration to negative. Or multiply.
Yeah. Yeah, you are multiplying here. I think that's what you said at the end?
Yeah.
Yeah.
So,
Skylar?
So does that context, like, the, rule of thumb for the others? So like you would do positive direction minus the negative direction?
Yep. All right, you wanna do the next one?
I thought you-
Did you have a question before Skylar dazzles us?
okay, so positive, so that example is when your friction is positive minus your
That's
negative.
if I1 had it that way.
Okay. So that, the I hat, J hat was in the other direction.
Yes. Or just the I hat.
Okay.
J hat's a separate equation.
Got it.
All right, J1 hat, I don't know if you're feeling up to it or not, Skylar, but do you wanna give it a shot?
I'll give it a shot. So assuming that your J1 going up is your positive,
Yep.
it would be Y sub 1 minus W. And that would be equals the mass form acceleration. And then, is it acceleration or is it,
Why do you think it won't be?
because acceleration is going to the right?
Therefore, what is the vertical acceleration? So it's 0. This, if you choose one of your coordinate axes to be in the direction of acceleration, then when I look at my two equations, one of them will be equal to 0. That is the point of it. There's a video I do where I solve, I think it's Boxall and Ramp, and I set it up so that the coordinate system, one is in the direction of acceleration, one isn't. That's the traditional way of solving it. And then I also do it where I go for the traditional vertical horizontal so that acceleration is not in the direction of either of them. And in my mind, it quadruples the amount of math that you have to do. Finding a good coordinate system greatly reduces the amount of work you have to do. All right, next, one last equation.
Okay, so you got you got weight W2 minus FT equals mass 1, mass 2, my apologies. A. Show hands.
Those A's are the same, which makes it solvable.
Substitution.
Jack, I think that was, Tristan? Tristan or Jack?
No, I think my question was, why did we do W first, but because we said down was positive.
Yeah.
So is that the direction he's moving in, that's the positive direction? Like, because,
I had the accelerate, when you set up the system, you can either set up the arrows in the direction of movement or the direction of acceleration. In this case, it would be the same. There's a video on book attached to a coffee mug problem, and the book's going up a ramp. That's a situation where the direction of acceleration and the direction of velocity are opposite, and you decide which way you want to make positive. In that case, since acceleration and velocity are opposite, if you choose the direction of velocity as the positive direction, you would expect a negative acceleration. If you choose the direction of acceleration to be positive, then your velocity is negative, which wouldn't show up at this point. Yeah, velocity is not part of this at all. Did I answer your question, Tristan?
I get it.
Okay. Skylar?
So, because you have two different objects,
Mm-hmm.
their directions are two separate things, right?
Right. Yep, okay.
Yeah.
Sorry, so we've now gotten through E. The first S.
Where does, acceleration due to gravity come in?
I'm glad you brought that up. That's a nice segue into the first S of substitution. As you look at this, do we have an independent independent formulas for anything on here? When I say independent, it is not problem specific. No matter what problem we do, this formula is always going to be true.
Acceleration due to gravity.
That shows up at this point. If I take an object and I drop it, and I demonstrated that for you just in case you've never experienced anything falling before. So as I drop the object, ignore air resistance. What are all the forces acting on it as it falls?
Gravity.
What are the force? I'm nitpicking here. Tell me the force that's acting on it.
Positive gravity.
Gravitational.
Gravitational pull.
Sure.
Gravity pull.
I didn't think of gravitational force or force due to gravity. Again, gravity, huge topic.
Okay.
We just want one small aspect of it, the force aspect.
Force due to gravity.
And if you're close to the planet, what's another name for the force due to gravity?
Gravity. Of force. It's a per.
Ignore Ibrahim. What's the other word for force due to gravity? For something that is near the surface of the planet or moon.
Is it mass?
So if I cross somewhere,
Weight.
yes, wait. Yeah. Mass, not a force. I know for those of you who have had a bunch of biological sciences, they often use mass, something in kilograms, as a weight in physics. It is not. Please, don't confuse mass with a force. Please. All right, so if I have an object that's just plain old falling, so object falling, I have the force due to gravity acting on it, or its weight. I plug into F equals ma. The force I will make down positive. It's a one-dimensional problem, so I get away with that. So I have weight is equal to mass times, what's the acceleration called when something's in free fall?
Gravity. Force due to gravity.
Acceleration.
Acceleration due to gravity.
Yes.
Awesome sauce.
Symbolized by a lowercase g. This is a formula that is going to be true. Now, unfortunately, and this really is going to pet peeve for me. If you have one of those audio readers that will read text, at some point in a physics textbook, this formula is going to show up. And every audio reader that I have heard will look at that and read it as W equals milligrams. It's not milligrams. It's mass times the acceleration due to gravity. And what's the acceleration due to gravity in general on Earth?
9.8.
7
Meters per second.
meters.
Going for the units there. Now, what is it besides 9.8? It depends upon where you are. It is not a constant, despite what some people might believe. And in Winston-Salem, what is the value for G? Actually, more specifically, here, what is the value for G?
9.768.
So close.
9.798.
Yeah. So so the substitution phase is basically, I'm gonna rewrite this one, so this becomes M2G minus the tension equals M2A. This equation right here, I'm gonna do two things at once. This over here is 0, so I'm just gonna add weight to the other side. So I get Y1 equals M1G. And then we've got that first formula up there with friction. And how do you deal with it?
You know, you leave it alone.
All right, so why don't we leave it alone for the first time? So we'll just, this is for you, Jack.
Thank you.
This is, the abbreviation to just say it's frictionless. This is the Greek letter mu. It is the symbol used for the coefficient of friction. The S is static friction, the coefficient of static friction. Static friction means that the two objects are not sliding against each other. If it does slide, you have mu sub k, the coefficient of kinetic friction. This is the stuff you use when it slides, this is when it doesn't slide. That will become more critical in a moment, or less critical depending upon what you do with your life. So we will ignore friction to start with, and I have tension is equal to M1A. This middle equation doesn't do anything for us in this particular time. We can find what the normal force is in this case, but assuming I know what the masses are. But in a frictionless situation, this is not gonna help us at all. So I'm just looking at the first and third equation. I'm solving for A. I have two unknowns here in theory. Let's assume I know what mass 1 and mass 2 are. Let's assume I know what planet it's on. So therefore I know mass 1, I know mass 2, mass 2, mass 1, I know G. I have two unknowns, tension and acceleration. How do I solve it? Sure. What are you substituting into what? This is technically part of the solve phase.
Well, acceleration due to gravity is 9.8.
Oh, do you want to start putting numbers in?
No.
The point at which you put numbers in really depends upon you. Justin?
Would you put, M1A in, the third equation?
So, since I have a formula here for what the tension is in this case, I can plug that in here. That is one method to go, so let's do it that way first. M2G minus my tension, which is equal to M1A, equals M2A. I just did that substitution right there. If I'm solving for A, what do I do next?
Solve.
I heard something, after I heard something, there's somebody else said something.
Isolate A.
Yes, so how do we isolate A?
Well, you'd have to divide. Wouldn't you? The M2.
Not yet.
Oh, okay.
Gotta do, we haven't isolated the A yet.
Would you add the M1A to M2A?
Okay, we need to get all the terms of A on one side. So I got M2G is equal to M1A plus M2A. Now what?
Can you divide? The M1 plus M2 out.
Okay, let's factor A out first. So that's M1 plus M2 times A. And now, Skylar's favorite thing at the moment apparently, divide. So now we divide both sides by M1 plus M2. And what I'm left with is my acceleration is equal to M2G divided by M1 plus M2. It's as simple as that.
That's your answer?
Yeah, then we can stick numbers in if we have to. Notice, this is the acceleration of mass 1 and mass 2. I know if that string were cut, if the tension became 0, mass 2 would be in free fall, the acceleration of mass 2 would be g. But basically I am multiplying g by this, which it has to be less than 1, assuming my masses are not 0.